Good afternoon, everybody. Thank you for being here. So I will start. Graphenest is a nanotechnology startup based in Portugal, and our mission is to protect electronics from electromagnetic interference with the sustainable coatings and plastics. The big problem that we are solving is electronics and the communication device need to be protected and shielded from electromagnetic interference, which can result in noise, data loss, and device failure. This includes a wide range of products and systems like smartphones, vehicles, cables, batteries, and even 5G radar LiDAR devices. All of these systems and products require shielding to work reliably. The current shielding solutions predominantly rely on metals, which are less sustainable, suitable for the MI shielding landscape. Metals compared to plastics are denser or heavier, if you prefer, and require a high energy intensive manufacturing process to be produced. Furthermore, the shielding effectiveness of these metals offer a more efficient performance for high frequency electronics. Complicating matters further, the European Union relies heavily on metals and minerals that are imported to our region, with 2/3 sources from overseas. So a strong motivation exists from the automotive sector and electronics sector to innovate. Their aim to decrease not only the weight but also the production costs, and with that enhancing the vehicle range without compromising the safety and compliance of the standards. Our solution, we offer a graphene-based conductive plastic and coatings for MI shielding, providing a set of features like lightness, versatility or adaptability, and effectiveness, while increasing the sustainability and circular economy of the supply chain. Our value proposition, is based on a few key advantages. That it starts from the production cost that can be more than 15% and reduce the weight by up to 75%. We are talking about electronics housing. On top of that, our clean technology to produce graphene can use recycled graphite, which is highly scalable, modular, and cost-effective due to the implementation of 3R, as we call it, approach in our process. So reduce, reuse, and recycle, which will enable a fully circular economy. Manufacturing-wise, or for our clients, graphenest shielding solutions benefits from being produced with fewer steps, less time, and lower costs. In terms of the business model, Graphenest is centered around providing a license-free shielding patents. In return, what we ask is for exclusive selling rights to the graphene materials that we produce during the period of the supply contracts. Typically, our contracts are around 5 years as a standard. This approach not only facilitates the adoption of this new technology, but also the execution of the projects. And we do it through joint development agreements. So on these partnerships, we invest together with our clients, and we continue during the process to continue to expand our portfolio of patents and of course the knowledge. Our target clients are tier 3 manufacturers, including compounders, master batch producers, as well as injection molding, chemical materials, and polymer manufacturers. By establishing enduring relationships with these companies, we can provide a higher value across the value chain and for the mid tiers, so tier 2 and tier 1, as well as the OEMs. Since graphenest is ensuring the long-term sustainability and growth of the solutions. In terms of the market and the application, we are just the air mobility market is, well, as you know, is experiencing a rapid growth and projected to be above 400 billion euros by 2025. Even so, we focus on the still substantial market opportunity of 15 billion for the shielding applications. So these applications span across multiple sectors, including cables, electronic enclosures or housings, printable electronics, and in mold labeling, just to name a few. To provide a more precise breakdown, just the cable industry alone accounts for more than 400 million euros in attainable market share when or attainable market when operating at full scale. However, this figure only represents 2.6% of the overall shielding market share, right? And this is just the beginning. Even though we are focused on the shielding market right now, here you can see that there are several examples of pilots and on our long-term roadmap that will take advantage of the knowledge and capabilities developed inside of graphenest and with our partners to reach and incorporate these technologies into other high-value verticals like the electrical and thermal applications, as you can see. Over the past 8 years, graphenest has forged lasting partnerships with universities and associations, and of course, we raise grants to be able to validate our cutting-edge technologies and deliver the high-performance solutions to the market. Now, I would like to hand over the floor to João. Let me stop my presentation.
Okay, I think you can see my screen now. Yes, okay, great. So good afternoon, everyone. It is a pleasure to be here on this first edition of Innovationschau. My name is João Rodrigues. I'm a research and development engineer at graphenest, and now I'll talk a little bit about graphenest technology and our developments, more specifically into the shielding market, so our shielding products. Just to introduce you to graphene. Graphene is basically a single layer of carbon atoms arranged in a honeycomb-like structure. It is not a new material, but it's still quite recent. So it was first experimentally identified in 2004 by two researchers at the University of Manchester. And due to this discovery, they won the 2010 Physics Nobel Prize. Since then, many of its characteristics and applications have been researched, and all this due to its great properties. For example, mechanically speaking, graphene is a very interesting material. It is stronger than steel, while being very light and flexible at the same time. In terms of optimal properties, monolayer graphene, that is graphene that is a single atom thick, it is compatible with transparent electronics because it only absorbs around 2% of the radiation in the visible range. And since graphene is just carbon, it is a material that is very stable and chemical resistant. Well, at graphenest, we develop a liquid phase exfoliation technology to produce graphene powder in a sustainable and cost-efficient way. So we use natural graphite as a raw material, but recovered graphite can from end-of-life batteries or other sources can also be used. So we are reducing our environmental impact. The graphite is thinned into a few layer and multi-layer graphene powder, and the product that was not fully exfoliated can be inserted back into the production line, and the solvent can also be partially recovered. So we are contributing to a green and clean technology. We also have capabilities to do lots of lab characterization of our material and samples. So we can do assessments of shielding effectiveness, microscopy, electrical and chemical characterization, and also rheological properties of fluids and inks. And since our graphene has a good dispersibility and electrical properties, we have been focusing in the development of solutions for electromagnetic interference shielding, which is also known as EMI shielding. Well, what is a EMI? EMI is basically a disturbance of electromagnetic waves that can affect any electronic that is not properly shielded. This type of interference can be from a man-made source, for example, a Wi-Fi signal or Bluetooth, a power line, a radio station, or even something that occurs naturally, like a thunderstorm or a solar flare. This type of disturbances can be just temporary, for example, some data loss or introduction of noise into the electronic circuit, but it can also be something more serious like a permanent damage of a component. So it is very important to have every electronic system properly shielded according to the environment that is inserted and to the final requirements for its reliable operation. And the shielding can be achieved by surrounding this device or equipment with a material that is able to protect it from external signals, as well as preventing generated signals from reaching the surroundings and affecting other components. So it is very important the choice of material that you are using in your shield. Its properties are also very important. For example, the thicker the material that you have, the more it will be able to attenuate from electromagnetic radiation. But also the electrical conductivity and magnetic permeability are very important characteristics. Graphene in particular stands out since it is a material that is able to absorb more electromagnetic waves than metals. And so it's contributing less to the signal propagation due to reflections of the shielding material, because metals behave like a mirror, and when they reflect back the electromagnetic waves, they can still affect the surroundings if they are not properly shielded. So ideally, you want a material that is able to absorb and not reflect. Nowadays, EMI is more important than ever in the e-mobility sector due to the increase of the number of electrical vehicles with extensive electrical systems and sensors, meaning that more shielding is necessary to counter all the disturbances that are present, not only caused by the onboard systems inside a car, but also from external transmission antennas or radars, for example. Currently, typical shielding solutions are based on metals, such as foils, screens, panels, enclosures, or even coatings. But metals are heavyweight, so they add weight to the car, and this will reflect in the negative impact on the battery life of the EV. So if we replace all these metal components by graphene-based solution, not only we can still keep the electronics safe and operating reliably, but at the same time we are improving the range of the electrical vehicle by reducing the weight. Another important factor is that nowadays the data transmission inside the car from the infotainment systems to advanced driver assistance systems require high data rates and also consequentially operate at high frequencies. And the performance of metals, of shielding metals, decays at very high frequencies. But fortunately, we observe that our graphene-based solutions have the opposite behavior, and they work even better at very high frequencies. And this is something I will show a little bit later on this presentation. So we started to produce some solutions for the EMI market. For example, coatings and inks, we have solvent and water-based solutions that have really high conductivities and are able to attenuate the emission of electromagnetic waves by over 2,000 times. And since this is an ink, it is very easily custom made for each application. We can adjust the rheological properties, the content filler, the type of substrate to be applied, and even the type of technology to apply this type of inks. It can be via screen printing, for example, or spray coating. Depending on the final application, we can custom made our product. On the right side, you can see here an example of one of our works for high frequency printed electronics, where an array of antennas had issues with crosstalk between each antenna. So it was necessary to place a physical barrier, a shielding material in between the antennas to avoid the interference. So we developed a graphene-based ink that was able and we were able to coat it in between the antennas and keep them safe and operating without more noise from the neighboring antennas. And this is something very easy to implement since it is an additive method, a printing process that can be easily upscaled. Well, we also have been developing plastic compounds with our graphene for the electrical properties. For example, we have polyvinyl chloride, PVC, and also polypropylene, PP. And these are thanks to partnerships with Delta Technique and Hubron. But as you can see, inside the car, there are many types of polymers being used. So we are always looking forward to establish new joint partnerships, to develop new materials, and add them to our portfolio. So we are interested in many others polymeric matrices, for example, XLPE, PBT, PA, ABS, or even fluor polymers, because we believe that they can also be enhanced with our graphene. But going a little bit more into detail, we develop a cable prototype that uses a graphene-based polymer as the shielding layer. So because conventional Ethernet and data cables that are also employed by the automotive industry, they use a tight copper braiding mesh and aluminum foil for shielding purposes, as you can see here on the figure. So we are able to remove this braiding and replace it with our graphene enhanced polymer, which allows not only for a great weight reduction of the product, but also to reduce the production costs and increase the productivity, since the braiding process is very slow and is no longer necessary. So we can replace it by a standard polymer extrusion process, which is much quicker to produce. But based on the final requirements for your cable or the application where it needs to be used, there are two alternatives. You can go for the braidless shielding, so basically remove all the metal shielding and place a graphene enhanced polymer. But if you require even higher performance in terms of shielding, you can opt by a hybrid solution, where you use just a loose copper braiding, so you use less material with a bigger aperture of this braiding, so it's quicker to produce and it uses less metal. And this works very well to shield at low frequency ranges. But for the high frequency ranges, you can use a graphene enhanced polymer jacket, and this combined solution will work very well overall in the entire frequency range of operations. So you have the best of both worlds with the metal and also the graphene polymer. And just to conclude, I just want to show a little bit of data for those of you that are more interested in more technical side. I have here some data about the shielding effectiveness of our product, and also we compare it with some competitors. You can see here on the left figure, competitor one, it uses stainless steel fibers, which are heavyweight, and sometimes they are difficult to integrate into a polymer without degrading the mechanical properties. And competitor 2 uses the carbon black, which is tricky to disperse sometimes, and also it is difficult to achieve the proper electrical properties that are required for EMI shielding. And as you can see on the black plot, on the black bars, you have the volume resistivity. For a shielding material, you want the lowest resistivity as possible. And as you can see, our product, it achieved the lowest one. It outperformed both competitors. And these reflect also in the shielding performance. The blue plot shows the specific shielding effectiveness, that is the normalized effectiveness of our material to shield EM waves. And since it's normalized to the density of the material, we can compare different fillers and different polymeric matrices. So our material, while being lightweight, it has a very good performance. So again, it outperformed the competitors. And looking a little more into detail of the performance of our material, on the right side, you have the performance of a PVC enhanced graphene over a wide range of frequencies. So starting at 100 megahertz up to 90 gigahertz. And this is already in the E band, which is a very relevant frequency range nowadays due to 5G communication and even the development of new communication systems. For example, 6G, which should be out in a few years, hopefully. And these frequency ranges will be more common in the future. So we require new solutions. And as I said previously, our material works. The thicker the material is, the better it will work. But also the frequency is very important. And as you can see, the performance, the level of attenuation increases a lot. For example, a 3 millimeter sample at 1 gigahertz attenuates around 40 decibels. But if we are speaking about around 90 gigahertz, you get a performance, an attenuation above 110 decibels. So that's a huge increase in the level of attenuation of our material at very high frequencies. This is basically what I had to show you today. Now we are open to questions, but feel free to contact us anytime. You can send a message on LinkedIn or via email. So it was a pleasure to be here, and hopefully we'll continue our collaboration.